All right, we are on to our final category of rocks and my personal favorite, which is the metamorphic rocks. So, if we remember that our igneous rocks are created from melting, they're molten rocks, right? Our sedimentary rocks were made from little tiny pieces being broken up and carried by water and wind. Our metamorphic rocks are our most resilient rocks, all right? So we think about metamorphic. If I were to metamorphosize, right? You think about butterflies that metamorph from a larva in their cocoon. And that's kind of how metamorphic rocks are. So, metamorphic rocks started out as another type of rock, either an igneous or a sedimentary rock. And they were exposed to intense pressure and temperatures. So, things like, continental plates smashing together or a volcanic eruption cooking all the rock around nearby. Or maybe they were trapped in between a fault line for an earthquake, or just sometimes the sheer weight of our massive planet is enough to crush these rocks. So, intense temperature, intense pressure has made these rocks what they are today. Because of that, our metamorphic rocks are going to be tougher, right? I'm not going to really try to break this because that'd be sad. But, if they're a little bit more tougher, they don't come off in my hands the way that my sandstone did, right? I don't have little pieces coming off. Okay. I don't have little flakes coming off the way I did with the obsidian when I broke the obsidian. So they're much more tougher because they have literally been cooked and smashed by the inside of our planet, right? Another characteristic you see in metamorphic is they're quite often very shiny. Ooh, look how shiny it is, right? Very shiny. So these 5 samples here, we're going to actually look at what their original rock form was before they were crushed and cooked by the earth. And sometimes you can see similarities, not always. And sometimes more one type of metamorphic rock can come from different types of sedimentary and igneous rocks because it depends on the temperature, depends on the minerals present. And the reality is if these are eroded away again, then they can become sedimentary rocks, or if they're eaten by a volcano, they can become igneous rocks. And again, that rock cycle continues on and on and on. So let's start off with our first sample here, and that's going to be quartzite. Quartzite is different than quartz, right? It has quartz in it. Okay, you can kind of see some shine to it, not a ton, right? Kind of a yellowish end here. And this yellowish end looks an awful lot like, oh, well, like our sandstone, as a matter of fact. In fact, quartzite comes from sandstone. All right. And if I look at the two, you can see some similarities, not a ton. They kind of have, I mean, these are purchased samples, so their shape is not really indicative of anything. But you can kind of see they have a similar granular structure. Okay, let me move this out of the way so my autofocus kicks in. You have a granular structure that's very similar, similar color. All right. Again, quartzite is called that because it's full of quartz, quartz and silica, which is of course what our sand is going to be made of, right? So if you imagine my sandstone for whatever purpose was pressurized and cooked by whatever earth process, million years go by, and you'll get your quartzite. This is much tougher. It doesn't Things don't come off the way they do versus my sandstone. I can just do this and now I've got bits of stuff in my hand, right? So again, a lot tougher, more resilient because it has survived those the pressures of the earth. I like to think of metamorphic as I'm a child of the 80s and 90s, so I grew up watching Power Rangers. If you think of these as the Mighty Morphin Power Rocks, right? They got their superpowers not from aliens in the case of the Power Rangers, but our Mighty Morphin Power Rocks, they have metamorphed. They've morphed in time into a new type of rock. They're stronger, they're tougher because of that metamorphosis. So again, quartzite coming from our sandstone. Very popular one, which makes sense if you think about where it's from, is going to be marble. Very nice and shiny. It's very pretty, right? Very sparkly. Again, that sparkling. I'm trying to get to catch the light a little bit more. That sparkle is very common in our metamorphic rocks, and so marble is going to be a classic example of that. And marble actually comes from limestone. Okay, so just like our limestone was used extensively for, building, marble does too. And the nice thing about marble is, again, metamorphic rocks are nice and tough, right? And so you think about how many marble statues we have from a long, long, long time ago that are still around. You can go to Pompeii and see a lot of statues have survived, even though giant volcano. So really a nice option for sculptors. Okay, again, you can kind of see some similarities in their structures. Okay, you don't see any really flashy bits of color through here, nor do you through here. You have that sparkle, which is going to be your grains have been crunched and cooked more, but and again, it's often hard. You're not going to just look at a metamorphic rock and be like, "Oh, I can magically tell that used to be a basalt," right? Unless you're a geologist, right? You can't always tell, and that brings us to my personal favorite rock, and that is a schist. So schist is really cool. I like it because it's shiny. I like shiny things, right? So it's nice and shiny. And sometimes you get these cool little, so you can like move in light. Oh, it's so shiny! It's so cool, right? This super shiny rock. And you sometimes get these little we call inclusions. These little dots here are going to be little bits of inclusions that are inside your rock. Now, schist, we can't always tell what its original rock was from. Shale is common. So one way you can tell this, and it's kind of hard to see on this sample is very thin, but you can kind of see some lines here. Let me see if I can get to focus a bit more. You can kind of see some lines through there. We call that foliation, kind of similar to the lines that we had in our shale. Okay, so shale is going to be a common source of schist, but not the only source of schist. This has been changed so much that it's hard for us to tell what it used to be. Okay, and more than one rock type is possible. You'll notice how much thinner it is, right? Than shale. Again, these were purchased samples, so they have been, carved to some extent, but they're kind of thinner and smushed. Another one that you see with that does come from shale. So here's my original shale here, and my schist, which has been smushed, but slate is definitely going to come from shale. Okay. Again, you can clearly see those lines along here that could have originally, whoops, started from my shale. So if you could compare my shale, my parent material shale, to my slate, which is my metamorphic rock, you can see a lot of similarities in the way they have those stripes. Okay, and so whether to look at the top of them too, you can see some kind of similarities between the ridges they have here. So yes, slate quite often comes from shale, but shale can also become schist depending on what type of activity started the metamorphic. Again, it could be something like a volcanic eruption, it could be plate tectonics, it could be an earthquake, it could be lots of different things that happen on the inside of our earth that create stress for rocks, but that stress makes them stronger. That's why stress is sometimes good for you, is it makes you stronger. Too much stress will break you, but just like rocks, too much stress will break our rocks. But some stress will make you grow stronger. Okay. So again, this can turn into either of these depending on what type of pressures are put on it, either my schist or my slate. All right. Another example that looks, I think, quite a bit like its parent material is going to be gneiss. It's a German word. It's spelled Gneiss. One of those awesome puns is, why was the geologist so popular at the party? Because he's a nice guy. And again, nice is spelled Gneiss. And that's going to come from granite. Okay, so you can see some similarities here. You can see different colors, right? That's a big one, big different colors. Remember, this is going to be my intrusive igneous rock. It had time to cool slowly, so I have all those little coarse grained crystalline structures that then translate themselves into the gneiss form of that rock. And so this is a great example of what we call foliation, which we saw some of in my schist sample. But this foliation is going to refer to those, I'm going to move that off camera so my focus kicks in, to that banding pattern. See how it's like a striping pattern? Trying to get to focus. Come on, little guy. There we go. So the way it has these stripes here, that's what foliation is. It's very common in metamorphic rocks to have this type of banding. Um, not it doesn't automatically mean that it's a metamorphic rock, but if you see this kind of stretched out straight zebra lines, that's a very good clue that it could possibly be a metamorphic rock. And Nice definitely has that sample. And you can again see it probably has, well, it does have the same minerals as its parent material, granite, because you can see the different colors. So probably this one didn't have as much potassium feldspar. Potassium feldspar, what causes this pink bit here. Okay, so again, the key thing for all of our metamorphic rocks is going to be that they're tougher, right? They're often shiny, not always. They're often shiny. They are more compacted, right? You think about how compact my slate was, how compact my schist was. They're more resilient because they all started out as some other type of rock. And so that's how the rock cycle continues is one rock within its vast lifetime can be sedimentary one day, and then 2 million years go by and now it's going to be igneous, and then 5 more million years go by and it's going to be metamorphic, right? And so our earth has a limited amount of materials on it, and so it has to reuse the material it has. If you're going to create a new rock, you do so by breaking down old rocks. Okay, that is all of our videos for rocks. I hope you have fun going out and looking at rocks out in nature around you. Start your own rock collection again, like when we were kids. Thank you so much.